Today's lesson, we're going to look at the definition of the derivative. We'll be doing a lot of derivatives in this course, and this is just an introduction to it. But what it really is, it is a slope getter function, as they say. It can give us the equation of the slope, not just at one specific point, like this m tangent that we kept calculating last class, but can give us the equation for all possible slopes of a certain function. So this box here, you have to know how to use this, and it'll be easier to actually memorize this formula. It states that the derivative is the same thing as saying the limit of f of x plus h minus f of x over h as h approaches 0 is also the slope. So if I want to find the derivative of x squared plus 2, I can find the general slope for this function by getting another function out of it. I'm going to plug this into my formula, so we'll say f prime of x is equal to the limit as h goes to 0, and then I'm going to plug in x plus h into this function of f of x. So x plus h is going to go in for where the x is. Okay, so that's what I'll have. And then my formula says minus f of x after that. So I'm just going to write exactly what I have for f of x, which is x squared plus 2. And all of this is over h. So I'm just plugging into the formula that I have. Okay, so let's simplify the numerator here. So we have, if I expand the top, I get x squared plus 2xh plus h squared plus 2 and then minus x squared minus 2 all over h. So we can simplify some of the numerator terms here. I got x squared minus x squared, so that's gone. And then got 2 minus 2, and that's gone. So now we're just left with two xh plus h squared all over h. But I can factor out an h and then cancel the h top and bottom. So that's h times 2x plus h all over h. This h top and bottom cancels out, so we're left with the limit as h goes to 0 of 2x plus h. And now we're going to plug in the 0 in for h, so it's 2x plus 0, so it's 2x. So therefore, f prime of x is equal to 2x. So the derivative function for x squared plus 2 is 2x. Now I want to find the slope of the tangent line at x equals minus 1. Well, I already found my slope function, and this will give me all slopes for f of x. So all I need to do is plug in the negative 1, because we know that x is negative 1. And we're going to plug into our derivative here, so that's 2 times negative 1, which is negative 2. That means my slope is negative 2 at x equals negative 1. Okay, use b to find the equation of the tangent to f of x equals x squared plus 2 at x equals negative 1. We're just going to use all the information that we already found. So first of all, remember the format of finding an equation is y2 minus y1 is equal to slope times x2 minus x1. Hopefully that's a review. This is just a format to write or create equations. So we already have m. We found it earlier just above. M is -2. So that's okay. And we have 1 point. X is -1, but I need to find the other point for y. I need to find the actual point. So I can just use the equation that I have up here. So I'm going to plug in f of -1 so I can find my other coordinate. That's -1 squared plus 2. I'm just using the formula from above, that f of x is equal to x squared plus 2. Simplifying this gives me 1 plus 2, which is 3. So that means my point then is -1, 3. And now I can plug into my equation. So this will be y minus 3, because 3 is my y value. My slope is -2. And my x value is -1, or I'm just going to write plus 1 instead here. And then that is your equation. You could write into slope-intercept form if you want, but I would just accept it as that as well. So you can take the time to try this question. You follow the same steps. You'll do A first, find the derivative of this function. And then B, find the slope at 2. So you're going to plug it into your derivative, 2 into your derivative after. And then the last part is to make the equation. So you have your slope from B, and then you're going to need to find your y value using x equals 2, plugging it back into the original function. So I'm just going to write the answer here, but you can do this on your own and see if you get the right answer. So this is your equation at the end. So y minus 1 over 3 is equal to -1 over 9 times x minus 2. Okay, moving on to example 2. Find the equation of the normal curve, f of x is equal to root x, at x equals 4. So the normal line is just the perpendicular slope. So we're going to follow the same sort of rules or steps as the other question. We're going to find the derivative first by plugging it into the limit equation that we have. And then after I've found the derivative, I can find it as specific points if I need to for x equals 4. And then to find the normal, I just take the negative reciprocal of it. Okay, so let's get started and find the derivative. So f prime of x, plugging into my definition of the derivative with using limits, it's f of x plus h. So I'm going to, instead of having x here, I'm going to put x plus h. And then be minus f of x all over h. Now you have to think about the last unit now when we're solving for limits. We have a root sign. And generally when we have a root sign, we probably want to multiply by its conjugate. But before we do that, actually, we can probably make our lives a little bit easier. Instead of finding the general derivative, I can actually find the more specific derivative of when x is equal to, 4. So we can find the specific derivative at x equals 4 right away using this formula. And we can do that by plugging the 4 into where x is. So we have 4 plus h minus 4 root of 4 all over h as h goes to 0. Okay, so if I simplify this little bit, I would get minus root of 4 is 2 all over h. And then now it's easier for me to multiply by my conjugate. You could have done it up here as well when we're doing this, but then you're just gonna have to do that extra step for b. Okay, so I'm going to multiply this by its conjugate, which would be 4 plus h plus 2, and you'll do that top and bottom. And then you're going to multiply the numerator, together, like this. So that would give us 4 plus h minus 4. So remember to do your rainbows. And all this will be over h, the root of 4 plus h plus 2. I'm just going to move this up here. Okay, so I can cancel the 4 out of my numerator as 4 minus 4, which is just h. I still have h at the bottom. But now I can see that we can cancel that h out. Like that. And now we're okay to plug in the 0 for where the h is. So this will be 1 over 4 plus 0, which is just going to be 4 under the root sign then. So that's 2 plus 2 in our denominator, so that's 1 over 4. Which means my m normal, my slope for the normal to the curve, that's going to be perpendicular to the slope I just found. Which means I'll be a negative, it's a negative reciprocal of negative reciprocals, so we get negative 4. Okay, so now we're going to plug it into our equation. Well, it's in this format of y2 minus y1 is equal to m times x2 minus x1. Okay, we know what our m is, but actually I need to find is the y value first. Okay, so our y value would be f of 4 will give us our y value. And that would be root 4, which is 2. So I know my slope is negative 4, and then my point is going to be 4, 2. Okay, so now we're going to plug it in. So this will be y minus 2 is equal to our slope, which is negative 4, and then x minus 2. Or x minus 4, sorry. Our y value is 4. And that's it. That's going to be your answer here. So you can do that one and try it on your own. You want to find the derivative of f of x is equal to 1 over x squared. Just do that on your own time. If you have any questions, you can just ask later. That's everything so much.